let's make a Docker container. Let's containerize our application that we just wrote. And then we're going to spin up multiple instances of it. That way we'll have 3 or 4 servers running on our server. So we're going to create a Docker container for our app. There's a link here with a complete Docker file, but we'll just do this right now. I won't expect you to know how to write a Docker file by yourself. And it's only a couple lines, and I'll talk about what every line is doing. So I'm going to jump back to my computer. Actually, for this one, I'm going to write this on the server. It just saved me a little bit of trouble. Because I'm going to install Docker on my server. I don't really like Docker on my computer because it's a pretty heavy application. It takes up a lot of resources. But I'll run it on my server because that's where I need it. That's what's actually going to power my container. So let's see, where am I right now? Home gem, that's not where I want to be. I want to be in cd/var/www/our application. OK, we're all here. So next, let's create a Docker file. So we just call vi Docker file. OK. So the first thing we need to do is say what type of OS it's running on. So I said earlier the OS doesn't really matter. Well, it does, because there's always an operating system somewhere in the layer. You can't just have an application that talks to nothing. But in this case, we're going to use Node. Node has an official Docker image, and it uses something called Alpine Linux, or Alpine, depending on where you are in the world, which is a really, 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 really lightweight version of Linux. So it's super fast, no fluff. It only exists to run this one application. So we're going to use the from directive there. Say from, and I want to use node 19, so I'll say node 19-alpine 3.16. If you're saying, where did I get this exact node version and package name, just look up node docker, and it will link to the official repository. They maintain this image for us, so we don't have to do any of that work for us. It's already been built. Next, we got to give Docker, we have to set up Docker properly. So Docker by default, in this image by default, is going to run with a user called node. It doesn't run as sudo or ourselves. It runs as its own user. So that means we have to set that up for us in the operating system. So we can say run, on the next line, run make dir. Remember what that does? It makes a directory. -p. That's the command to make a string of directories if the first one doesn't exist. So we're going to make that in home/node. And Docker likes to run from the home directory. I like running from var www. Personal preference, doesn't really matter too much. But in this case, we're going to run our application within this operating system from the home directory of node. And we want to make a directory for our node modules. So /home node app node modules. And we want to change the ownership of the node modules to the node user. Node and node. And then we're going to change the ownership entirely in the app directory. Node app. There we go. So now we created a node directory, or we created an app directory within the node home repo or home directory, and then we change ownership to the node owner. Next, we need to set a working directory of where we're actually going to do all the work, where the Docker container is actually going to load up the application. That's pretty easy because we just created it. So home node/app.
You need a K in your make directory line.
Oh, thank you. Again, these things that I'll get all the way to the end and I'll see if it works, and then it won't work, and I'll be like, why? Why? Good catch. You need a K in make dir, not mdir. So we set our working directory. Next, and this is where it kind of messes with your head a little bit. Because we're making a Docker image from our existing application that we already wrote, we need to copy the files from our directory, right now, our actual computer, to the Docker container. So these are just sets of instructions for Docker. When we build the Docker container, it'll know what to do. So we need to copy our package star.json. So it's going to copy package.json and package lock. And we're going to copy everything else in that directory as well. Just being really explicit here. Or it's going to copy it to the home app, should I say. So note we didn't copy like node modules or anything else. We can run that with the npm script. It's going to install the node modules specific for this operating system. Next, we're going to set the user to node. And now we can run npm install from that package that we copied over.
We set on line 3 that our working directory was the node application. So, but on line 4, we have the relative address from our www app directory.
Mm-hmm.
Okay, so that relative directory things is referenced off of where the Docker file gets run from.
Yeah, the Docker file is always going to live in the application that you're trying to make containerized. So it makes it easy. You don't have to do any weird tildes and things like that. Just a little bit easier to reason about, but good question. So next, we switch the user to node. We're going to run npm install, this part of the Docker build. Next, we're going to copy everything over. So we're going to say chown node, change ownership to everything. So we're copying the ... is everything in our current directory now. The reason why we did the package JSON first, why we copy that over, and then we ran npm install is so all the packages can install first, and then we copy the rest of our applications over. You could probably do this in a little bit different order, but this is usually the best way to do it. So everything we copied over, we also did a chown. So we changed the ownership from our current operating system, which is owned by me, over to the node user as when we copy things over. And that's where like you start to, it gets a little tricky because sometimes you're within the Docker application and sometimes you're without. And that's why I think it's the hardest part to wrap around Docker files. But in this case, we are copying from our home directory. The last thing we need to do is, what's the point of writing a web application if we don't expose a port to talk to? So we're going to expose port 3000, so our container can communicate through that. And the last thing we're going to do is we're going to execute the command. We're going to run node. And in this case, we're going to run app.js. If you recall from the earlier exercises, app.js is our simple server. Yeah, we can bring up the WebSocket server and we can try copying that, but as we saw, there's a little bit of bumps there and that might take time to dive into. But you're welcome to run the index.ws.js file and create a Docker container out of that. But for now, I'm going to run my really simple server because I know for a fact it'll run every time with no issues. Then we write quit, and that's our Docker file. Everybody there so far? Yeah, okay, now it gets exciting. So, do we have Docker installed? I don't know, let's check. Let's run Docker. Not installed. Earlier I said you can use snap or apt. I did this when I ran through this previous times. I used snap. It got a little funky. So we're going to use apt because, you know, we know how it works. So apt docker.io. Oops, instill. And let's see if Docker is available. All right. So we just, for those who missed it, we just apt installed Docker. So now let's try to build our Docker file. Again, let's hope nothing went wrong. I didn't make a typo somewhere in there, which has been a common theme, but let's find out. So we're going to say Docker build. It's going to look for our Docker file where it is. We're just going to say -t to give it a name. We'll call it node full stack front end, just for now. We don't have to give it a name. It just makes it a little bit easier. So Docker build -t node full stack front end. Let's see if this works. Duh, I didn't tell it where to look. So let's try this again. Docker build st and the dot. The dot is saying, look right where we are in our current place. So we don't necessarily have to do that. We could do it from another directory, but this makes it easier. The dot's really easy to miss. Permission denied. Classic, classic. So you shouldn't have to do this, but I'm going to sudo it because that's going to make sure it works. Sudo bang bang. It's probably because when Docker was installed, it was sudo apt install. There's a way around that, but you know. Oh, so there's a typo in there. Manifest for node alpine 3.6 not found. So let me go open my Docker file again. Let's make sure I didn't type it wrong. From node alpine 6. And I'm just going to look it up just to double check that I have the rights. So I'm going to say node Docker. Let's try to find the right image. (19) Alpine 3.6. Yeah, that should be the right one. And let's double check, see what I wrote. From node Alpine 3.6. Yeah, that should be correct.
So this is one of like the default Docker environments.
Yeah, this is the official image for Node.js. Let's check this out. From Alpine 3.6. Yeah, we don't need that. 19. So if you want to look at, see like what's happening, you know how we imported that image from Docker, or at least we're still trying to? This is the Docker file for that image where it runs through, it sets an environment, it sets the operating system, Alpine 3.6. It creates that node user. Remember we said Docker, this Docker container creates a node user, and it runs through all these commands we see here. It downloads the Node.js binary from nodejs.org. And it goes through all these things. So it's Docker files on top of Docker files on top of Docker files. And that's awesome because we can compose things really well. And then that way, in some future reference, if we want to create a new application, we can just import our Docker file into that one. Node : is it a dash here?
Go back, yeah. Get rid of the dash after Alpine. It's just straight.
Yep. It's the little things. It's the little things. I'm glad you all are here.
Do you need to chown those when you're copying them over?
I don't think so, but you might be right. Good call. Doesn't hurt. Node. Okay, let's try that one. Yeah. Good call. Good call. So we forgot to change owner. We were getting a permission error. We forgot to change the owner to node again because it copied over the packages, but it still had me as the owner. And I don't exist in this operating system, so that's why it failed. All right, so let's say Docker image. Is that the one that'll tell me all my Docker ls, I think? Oh, Docker image ls. Docker image ls. So I just ran sudo docker image ls. In a better world, we would not have to sudo, but because I installed it with sudo, after now run sudo, I think it's okay. So now we can see that image we created here. And because we gave it a name, again, you don't have to, but it just makes it easier to look at. And it also created that node Alpine image that we pulled in. And the none, I'm not sure what this is because there's no name on it. So it could have just been like a bad run from earlier. I don't know. So next, let's try to run this thing and, see if we made a mistake somewhere along the way. By we, I mean probably me at some point. So we can run it with Docker. What is the exact command? I might need to look this up again. Oh yeah, it's docker run. And sudo it, just save my own mistake. Docker run. We're gonna say -d. -d will run in the background. That way it'll run and then it'll close itself out. Otherwise it'll stay open and then we have to open another terminal to do anything on the server. And then we have to do the -p, which is probably the most important one. So -p specifies the open ports. So we expose 3000, which is fine, but we need to tell it which port to expose on our server itself, our current server. So the format is outside port, our current server, then the inside port, our containers port. And we're just going to say 3000, 3000, pretty straightforward. And our image name, we can also use image ID. We'll just use image name, full stack front end. And there's already something running on port 3000, so we need to PM2 stop that our old server, index WS. There we go. And let's go ahead and try to run this Docker container again. All right. But let's see if it worked. Yeah. And we're back to our simple server again, but pretty cool. So now we just containerize our application. Great, that seemed like a lot more work, Jem, to do the thing we already did. Okay, you're right. Let's try this. What if we create another Docker container or another Docker instance, but we give it a different port? So now we can say Docker PS, whoops, always sudo. So now we have two Docker containers. One is running on port 3000, one is running on port 3001. I can create 10 more. As long as they're running on different ports, we now have 10 different servers or instances of our application on our one server. Okay, so what now? How do we tell Nginx to route to that? Well, first, let me talk a little bit about orchestration, how you generally do these things, and we'll round off with how do we get Nginx to actually connect to each of our Docker containers? So it's connecting to our default one on 3000. How do we get it to balance out the connection to all of our other servers?